All right, this is the last problem in section 3.7 on elasticity of demand, and we are looking at the price-demand equation. So given a different price-demand equation for a product is x plus 500p equals 10,000. Here, notice that neither x nor p is solved for, so you have a choice. Actually, you don't when you're looking at elasticity, you'll see. Calculate and interpret the following. So this is looking at the elasticity at a price of 4, elasticity at a price of 16, and then again, we're going to try to find unit elasticity. We're going to do that practice. Okay, so here is number 2. This is given. All right, so the first thing we're going to do is note that we're looking for E of 4. So we're going to first find E of P, which is equal to this negative P, that's the formula every time, negative P over X times dx dp. We need X as a function of P, and we need to find our dx dp. That's what we did before. So kind of a review of what we've already done. So looking at this equation, I need to solve for X as a function of P. So how would you solve for X here? Yeah, you would just subtract 500p from both sides. So subtract 500p from both sides. And when you do that, you get, and I just put it first, so it's x equals negative 500p plus 10,000. You could also write 10,000 minus 500p. But this is our demand equation, x as a function of p. All right, so we have that over here. We need x as a function of p, and we need dx dp. So what's the derivative of this? So dx dp is, and you can probably see it under that piece of paper, is negative 500, right? The derivative of this, just a linear, is negative 500. So what we're going to do is put this x and this p into this equation. So this is our big formula here. And this is our second practice at this. So notice I put the negative with the p. I divide by x, which is this, the negative 500 plus 10,000. And then I have the negative 500, which is the dx dp. Okay. So what's happened is that that gets put under here, and that gets put right over there. All right. Now you're going to do this, it's over 1. So you're going to take negative p times negative 500 and get 500p on top. So I'm going to write it that way. There's a nice equation. Now in Math Excel, they factor out 500. They do all kinds of simplification. No need. We don't need to do that. We're good. We know our algebra is perfect, so we don't need to do that. We'll just leave it like that. Now on this problem, it says to find E of 4. So I'm finding E of 4. And you should try it. Put 4 in here and see if I got 0.25. You need to check and make sure you get 0.25. And why is this inelastic? I'm using these. If E is greater than 1, elastic. Less than 1, inelastic. Equal 1, unit. So less than 1 means inelastic. 0.25 is less than 1, so 25 cents is less than $1, right? So it's inelastic, which means we increase the price. And to review what that means, that 0.25, it means a 1% change in price results in a 0.25% change in demand. Okay? That is E of 4. Now we're also supposed to find E of 16. So E of 16, plug that into this equation up here. See if you got 4. You can always stop this and check. And that is greater than 1, so that is elastic, which means you need to decrease your price from $16. Notice that's quite a difference in price. The first one was $4, and then we increase it to $16. It makes it hugely elastic. And again, reviewing, a 1% change in price results in a 4% change in demand. And that's part B. Part C is the unit elasticity. I'm going to turn this page over. here we have it. You take that equation that you found and set it equal to 1. Do you remember what to do here? You cross multiply like this. That times that equals that times that. Cross multiply. So the 500p times 1 equals negative 500p plus 10,000. All right, that's a cross multiply. Add 500p to both sides, and you get 1,000p equals 10,000. Now what do? That's right, you divide both sides by 1,000, and you get p is equal to 10. So the price should be $10. That is what creates unit elasticity. And that is the end of section 3.7.